Okay, well, we can finish this. These multiplications are very straightforward. You don't want to do more than that in the next step. At least a few of you tried to distribute the A through what you were going to get when you did this. It's okay. Once you've got the cobwebs out and got the rust out of your system, right? You could do that. I don't recommend it at this point. Okay, XH and HX are the same thing. They're both negatives. You got -2 of them. And you got your plus K. Then you can distribute. You get A x squared minus 2A x h plus A h squared plus K. Looks like you got that. Even skipping steps, and that's pretty good. Okay? Right now, I want to see it written out step by step. I don't want people making mistakes with this sort of thing. Okay? If you can possibly help it. Okay, well, this is of the form something times x squared plus something times x plus something else, right? Where A, B, and C stand for numbers. Little a and big A turn out to be the same thing, but they're not generally the same. A variable is case sensitive. If it's a little a, it's different, or that can be different from what you mean by big A. They're different variables. So we can say that this is the case with little a equal to big A. B is equal to -2AH, because that's what's in front of X here. It's not actually in front because of the way I wrote it. But you know, understand it can be rearranged that way. And C is equal to what? Well, what terms don't have X's on them? This one and this one, right? So C is equal to A H squared plus K. Well, now, that means that this graph here has this equation. If you just know what A, H, and K are, you can see what the numbers A, B, and C would be. Okay? So, that's equal to AX squared plus BX plus C for these values. Okay. Well, now in this form, we can get an awful lot of information.
Oh, your foot, I'm sorry. I forgot about it. I thought you were just like walking slow on purpose. It's not like really helping. Hey, don't feel bad, I have to just practice cutting.
I think that's enough room to write that. This is an important form of any quadratic function. It says y equals f of x equals ax squared plus bx plus c. Okay? Y equals 0. If and only if ax squared plus bx plus c equals 0. Okay? And that's true if and only if x equals negative b plus the square root of b squared minus 4ac all divided by 2a, or x equals negative b minus the square root of b squared minus 4ac over 2a. Shorthand for that, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Everybody recognize that? Typically, a lot of people in a pre-calculus class, often a majority, don't, which again says something about the algebra courses people have before they get there. Extraordinarily important. Although everybody should recognize that and remember seeing it, whether you remember it or not. Yeah, be a little rusty, okay? I think I mentioned I was in a school that didn't offer any courses below calculus. You had to be pretty smart to get in there. Science and engineering school. And I was in one of the higher level calculus courses. Not the highest level, but one of those higher levels. And most of the students in that class, I came to realize, didn't remember this. It was back at the time when math and science education was as strong as it's ever been in this country. Okay? So if you don't remember it, there's no shame in that. If you don't remember ever having seen it, well, I wouldn't be ashamed, but I'd be concerned. Okay? You know, some people just needed a refresher. I don't know what they were doing. Maybe they didn't have great memories. So anyhow, that's what we've got. It's a quadratic formula, and it's really important because it tells you things about the graph of the function. Okay? Among other things, if this is your function, it tells you the coordinates of these 2 points. What would the coordinate of this point be? What's the y-coordinate?
0.
0. And what did I just tell you?
0.
I tell you y is 0 if and only if x has one of these 2 values. Well, x is the x coordinate, right? So which of these 2 values do you think would be this one, this value or this value? It's the one that's less, because this is less than this, right? Which one of these would be less? What's the same in both of these and what's different?
Negative b plus and negative b minus is different.
Sounded pretty good. Again?
Negative b plus and negative b minus is the difference.
Yeah. Well, and really, you kind of want to focus on the fact that you have this, negative b over 2a, okay? And then it's plus let's say this over 2a, right? Or minus this over 2a, okay? Now, you really can't tell for sure which one of these is less unless you know the sign of a. If a is positive, then the one with the minus here is going to be less because you're taking negative b over 2a and subtracting the square root of something over 2a, okay? So, you might want to think about that, but yeah. This one, and there's another thing that the parabola opens upward if you vertically stretch it by positive number. If you used a negative number, you would have to put it on the other side, the x squared graph on the other side of the x-axis, right? It opened downward. So we can kind of argue that if a is positive, then this one is less because you're subtracting this rather than adding it to the negative b over 2a. So for a graph that opens upward at least, this will be x equals negative b minus x squared root all divided by 2a. And this is x equals negative b plus the square root of b squared minus 2ac. 4ac. I just said 2a. That's what my hand did. Okay. Right? Okay. So, right there, if you know a, b, and c, if you know what your function is, you can immediately tell where it goes through 0, where the graph goes through 0. Of course, the graph doesn't have to go through 0, does it? Okay? So, if the graph goes through 0, that's where. Okay? If the graph doesn't go through 0, that means that the square root is not a real number. Now, how could the square root of something not be a real number? What's the domain of the square root function? But we haven't talked about the square root function. You can't take the square root of a negative. At least you can, but it's an imaginary number. It's not a real number. Okay? So if you get a negative under here, you're done. It means the graph doesn't go through 0. It means it's either all the way above or all the way below the axis. Okay? Above, opening upward, below, opening downward. Right? Okay? And it's possible that this thing under the square root could end up being 0, which means that both of these would be the same. Yeah, if you add 0 to something or subtract 0 from something, you're going to get that something. Okay? Okay, so that's one important thing. Now, another thing is, I can write another way. To write this as negative b over 2a plus or minus the square root of b squared minus 4ac all divided by 2a. Okay? Well, because that's just distributive law. Okay? Dividing by 2a is the same as multiplying by 1 over 2a. So 1 over 2a times this plus or minus this has to be 1 over 2a times this plus or minus 1 over 2a times this, which is what you get here. So this negative b over 2a is kind of in between these, isn't it? Because You got negative b over 2a plus something and negative b over 2a minus something. Same thing. So negative b over 2a is right in the middle of these two. Okay, well, this is a line, x equals negative b over 2a, right in the middle of these. The x squared graph is symmetric with respect to the y-axis. Part on this side is just a reflection of the part on this side, and vice versa, right? Okay? That line is the axis of symmetry. The vertex is the point of the graph that's on the axis of symmetry. It's either the highest or the lowest point on the graph. Okay? To find the coordinates of the vertex, you just let x equal negative b over 2a and plug that in. Up here, and it tells you what y is. Okay? All right, y coordinate is f of negative b over 2a. F of negative b over 2a means x is now negative b over 2a, so x is going to be that, x is going to be that. Of course, that's just going to be a number. Okay? You know, depending on your quadratic function, b is going to have a value, a is going to have a value. Okay? So what I'm going to ask you to do for homework for next time, simply I'm going to give you a couple of quadratic functions, okay? Ask you to find their zeros, okay? Then ask you to find negative b over 2a and show that it's halfway between your zeros, okay? Reinforce that idea. Then plug that in for x. I should say just plug what you get. And that's your y coordinate. That tells you where the vertex is. If you know where the vertex is, then you know what your vertical shift was, and you know what your horizontal shift was. Think back of what you've done, okay? Make sense? Should be a pretty easy assignment. I'll make the directions really explicit. I want you to do a few of these to get it in your head, and then we'll see where we go with that to get the whole theory of quadratic functions. I'll also have copies of Chapter 2 of the textbook for you, okay?